Bright Duty. Every student matters.
Hello children, welcome to the session. In this session children, we are going to discuss a few question and answers from the topics that we have covered so far. So the first question is on your screens guys. And it says, give an experiment to show the magnetic effect of electric current. So children, the question is asked in the form of an experiment. So whenever a question is asked in the form of an activity or an experiment, how do you go about writing the answer? You will first write the aim of the experiment, that the aim of this experiment is to show the magnetic effect of electric current. Then you will write the materials required, and finally you will move ahead with procedure, observations, and finally conclusion. Okay, so this will be the format for the answer, and this question can come up to 5-mark question. Okay, so children, in materials required, you will write that you will be needing the tray of the used matchbox, you will be needing a compass, you will be needing a bulb, a key, and a battery or a cell. Okay, so children, first of all we will learn that how are we going to make the circuit for this experiment. So children, what we are going to do is we will take the tray of the matchbox, the one you slide inside, you will take it and you will place a compass inside it. So children, each one of us know that the needle in the compass is actually a tiny magnet, right? So it always points in the direction of north-south. Okay, so you will place this compass inside this tray and you will wrap this tray with some turns using a wire. Okay, you will use this wire and wrap it around the tray and connect the two ends of this wire to the circuit. And in the circuit we have this cell, we have this key, and we have a bulb like this. Okay children, so our circuit is complete. This was all about the setup part. Now what we are going to do is, first children, we will bring a bar magnet, a piece of magnet, any magnet you can take. It is not necessary to take bar magnet, but I just said you can take bar magnet also, and you will bring it near this compass which is placed inside the tray, right? And what you're going to observe, you will observe that there is the deflection in the needle of the compass. Okay, now remove this piece of magnet and switch on the key, and you will observe once the current starts flowing through the circuit, you will observe that you will observe a similar kind of deflection in the needle of the compass as you observed in the case of when we brought the magnet near the compass. So this activity proves that electric current has a magnetic effect, and this effect is known as magnetic effect of electric current. Okay children, so the conclusion is we have proved that the electric current has a magnetic effect. Okay children, so let's move to the next question. The next question is, who discovered the magnetic effect of electric current? Okay children, so children, it was Hans Christian Ørsted who discovered the magnetic effect of electric current, and he was a Danish physicist, and he discovered that an electric current produces magnetism. And how did he discover this? As we have done in the activity, he observed such case accidentally. Okay, it was one of his lectures in 1820 that he accidentally discovered that an electric current changes the direction of a nearby compass needle. That is, suppose this is a wire through which current is flowing and you have placed a compass near this, then you can observe the change in the direction of the needle of the compass. And why does this happen? This happens because whenever the current is flowing through the wire, this wire will start behaving like a magnet, right children? So he observed it, and he was the first person to observe this. Okay, so let's move to the next question. So the next question is, children, name the type of mark which we should look at an electrical appliance before buying it. So children, if we are going to a market to buy some of the electrical appliances, say we have to buy a bulb, or we have to buy something like an electric press, an MCB, or fuse, anything if you buy, you have to check for the ISI mark. It is the international standard mark, children. Okay, so children, ISI mark is the mark of its quality. So you should always buy quality electrical appliances for your safety. Okay, so you should always check the ISI mark on the electrical appliances before buying them. Okay children, so let's move to the next question. Briefly mention which part of the symbol of battery shows the positive and the negative terminals. Okay, so children, what is the symbol for a battery? Suppose we have a battery having two cells. Okay, so how are we going to make its symbol? We will make two pairs of parallel lines, one with the longer and other one is shorter. So children, the longer and the thinner line always represents the positive terminal of the cell, whereas the shorter and thicker one represents the negative terminal of the cell. Okay children, I hope this is clear, and if you want to observe it through a cell, you will observe that the metal capping part, this side will be positive terminal and it is written on the cell as well. Okay, whereas the other side represents the negative terminal. Okay, so let's move to the next question. Name the device used these days in place of the electric fuses in electrical circuits. So children, nowadays which device is used in place of fuse as a safety device in electric circuits? So children, nowadays MCB is used. MCB, miniature circuit breaker. It is used in place of fuse, and I am not sure if you would have seen fuse these days because mostly MCBs are used. And children, there is a benefit of using MCB in place of fuse, which is that you just have to switch it on after a suppose excessive current flows through the circuit. Then what will happen? This will automatically be switched off. It will be automatically switched off. Okay, and all you have to do in order to restore the circuit, you will just have to switch it on. Okay children, so this is the benefit of using this over MCB over fuse. Okay, the next question is mention the name of the two devices that work on the basis of magnetic effect of electric current. So children, name any two devices that work on the basis of the magnetic effects of electric current. So children, devices like radios, electric motors, your mics, all these devices works upon the magnetic effect of electric current. Okay children, so these are all the devices, and I am sure you will be able to find many other devices which are based on this principle. Okay, next question is, who discovered the magnetic effect of electric current? Is it A. Joule, B. Maxwell, C. Oersted, or D. Newton? So children, I am sure all of you know the answer. The correct answer is C. Oersted discovered the magnetic effect of electric current. Let's move to the next question. The safety devices used for electrical appliances is fuse, resistance, connecting wire, or none of these. So children, the safety device used is A. Fuse, and it is based upon heating effect of electric current, right? It is based on the heating effect of electric current. Then let's move to the next question, which is write a short note on magnetic effect of electric current. So children, magnetic effect is the effect which is induced whenever the current flows through a wire or any conductor. Whenever the current flows through a conductor, the conductor starts behaving like a magnet, and we can verify this by placing a compass near the wire through which the current is passing, and if you observe the deflection in the needle of the compass, then this will prove that there is magnetic effect of electric current. Okay, and you will have to write all of this if this question comes for a 2 or a 3 marker. Okay children, you don't need to cram anything, just remember the concept and you can write it in your own language. So what you have to prove here? You have to prove whether there is magnetic effect of electric current or not. And for this, what you are going to do, you will just take a circuit, simple circuit through, and place a wire in this circuit, and whenever the current will flow through it, place a compass near the wire, and if there is a deflection in the needle, it means that there is magnetic effect of electric current. Okay, clear? So children, this was all about the question and answers from the session, and I really hope that you would have understood it really well. So thank you so much for your attention.